Hey everyone, this is Miss Denton, and in this video I'm going to be working on SOL G11. I have to admit this is my least favorite of all the SOLs, and it's really because of all the formulas you need to know that are not given to you on the formula sheet. So whenever I run into a formula that we're going to need to know, I'm going to make a big deal about it. I'm going to highlight it. I really think it'd be a good idea for you to put that on your need to know list, and we'll move forward from there. This SOL completely focuses on all things to do with circles. Okay, so first video is going to be about the properties of a circle here. Let's check it out. We've got all these circle formulas to know. I've broken it up into angles versus segments. So let's look at the angles first. First is the central angle. This is the easiest one. So we'll start out simple, build our way up. The central angle is exactly equal to the arc that it creates. So here, the angle at the center is equal to the arced measure, the arc degree. So here, the measure of angle ABC is exactly equal to the measure of arc AC. Okay. Another fairly simple formula to know is the inscribed angle formula. An inscribed angle is an angle where the vertex is on the edge of the circle. Look at where that vertex is. It's on the edge of the circle. So if the center is about here, this vertex has been stretched twice as far to be attached to the edge of the circle. So what happens is the angle is now equal to half of the arc's degree. Half of the arc's degree. So here, the measure of angle ABC is equal to the measure of arc AC divided by 2. Half of it. Let's see these two formulas in action. Got some examples down below. Well, this first picture is certainly a central angle. Look at where the vertex is. And we know, without even reading the problem, that the central angle is exactly equal to the arc measure. So let's run with that. It says, given the measure of arc PSR is 225 degrees. All right, from P to S all the way around to R is 225 degrees. But we are asked for angle, okay? We're asked for the angle measure, POR. Now, angle POR is an acute angle. So it can't be equal to 225 degrees. In fact, we need to find the measure of the arc that goes with this angle. Well, something we know about circles is the total degree measure of the circle is 360 degrees. So I'm going to start with 360 degrees, subtract that 225 degrees, that's going to give us the arc that we're looking for. 360, take away 225, leaves me with 135 degrees for arc PR, and since the measure of POR angle is equal to the measure of its arc, then the measure of angle POR is equal to 135 degrees. Dark down in the corner. Okay. Our next picture here is asking about angle DAR. Be really careful here because there's a inscribed angle out on the side, and then there's a central angle here in the middle. So you're kind of mixing the two together, a central angle and then an inscribed angle. Okay. We've been given the inscribed angle measure 34 degrees. We're asked for the central angle measure DAR. DAR. Okay. So first we need to know what we what to do with an inscribed angle. Inscribed angles are equal to half of their arc measurement. Half of their arc measurement. So the inscribed angle RBD is equal to its arc, which is arc RD, divided by 2. Well, that angle measures 34 degrees, and that's equal to the measure of arc RD divided by 2. To figure out the measure of arc RD, I need to multiply both sides of this equation by 2. 34 times 2 is 68 degrees. So the measure of arc RD is 68 degrees. Now, the measure of angle DAR is the central angle, and we know that a central angle is exactly equal to its arc. So if the arc measure is 68 degrees, then the central angle is 68 degrees. So the measure of angle DAR is also 68 degrees. Okay, in this last example here, we are trying to find the measure of angle y. We're trying to find the value of y. Well, angle y, I'm going to draw out these rays here. Y is the measure of angle q, and angle q cuts through at S and T, which means arc ST is the arc that goes with this angle. All right, well, I see another angle that goes with arc ST. Look over here, follow T across and we hit R. Follow S across and we hit R. So this other angle up here, angle R, also cuts through at T and S, so it also shares the same arc. That's called overlapping arcs. So whatever the angle measure here is at Q is equal to whatever the measure here is at R. Now, I think we have enough information to figure out what R is. Check out this triangle situation. We have a vertical pair of angles here, so 92 degrees and 92 degrees. Now we know 2 out of 3 measures in this triangle. We know that a triangle adds up to 180 degrees, so 180 degrees, subtract 92, subtract 50, is going to leave me with that third angle measure there. That'd be 38 degrees. So if angle R is 38 degrees, and it's congruent to angle Q, then Y is equal to 38 degrees, because they share the same arc. Okay, that was our last example of the angle formulas for circles. In our next video, we'll be looking at the segment formulas. Thank you.